Go.
This is a tutorial over 7.5. In 7.5, you're going to be still working with algebra, with exponents, but now we're going to be focusing on dividing exponents, okay? Example, if I have x to the 5th power divided by x to the 2nd power. Well, when we were doing the fraction chapter, what we said to do was to spread it out and then cross it out. So that would give me 5x's on top and 2x's on bottom, and then we said we'll cancel them. So that would cross one of them out, cross another one out, and so you would have 3x's left. So you said this was equal to x to the 3rd power. Still the same idea, but now they want you to try to use a shortcut. Well, if when we multiplied, we added the powers, well, what do you think we're going to do when we divide? Well, obviously we're going to subtract the powers because you got 5 of them here, 2 of them there, subtract them away, and that's how you ended up with x to the 3rd power. So you can either spread them out and cross them out, or use the shortcut, which says to subtract the powers. So either way you do it is fine. If you have x on top of x, well, if you did it the old-fashioned way, you know this would cross out. And if everything crosses out, that leaves you with a 1. If you do it the shortcut way, you would have 1 minus 1, which would be x to the 0, which we said previously that anything to the 0 power is 1. And that's why that's the definition of what x to the 0 power is. So let's use this example. If I have 10x to the 7th and I'm dividing it by 5x to the 2nd. If I'm doing it the way we did in the fraction chapter where I expand it and cross out, I'm going to prime factor 10. That would be 2 times 5. And then I would have 7x's. On the bottom I would have a 5 and then x squared, so I would have 2x's. My 5's would cancel as well as 2 of my x's. And that leaves me with 2x to the 5th power for my final answer. If I did the shortcut, well, 10 divided by 5 is going to be 2. And then if I subtract my powers, 7 minus 2 would give me x to the 5th, and I got exactly the same answer. Okay? Now, if you have x to the 4th on top of x to the 6th, okay, if you expand it, crossed out, you would have 2x's left, but remember those 2x's are left where? On the bottom. And so you had to make it into a fraction because you remember you couldn't have topless fractions. If you use the shortcuts, if I subtract the 2, well, there's more of them on the bottom, so subtract 6 minus 4 and leave the 2 left on the bottom. It makes sense that where there were more of them, that's where the leftovers would be. You never want to have a negative power. So don't go 4 minus 6, go 6 minus 4 and leave it where there are more of them. So let's take this problem. X to the 5th, y to the 6th z on top of x to the 4th, y to the 3rd z. Instead of writing all those x's and y's out, let's see if we can do it by the shortcut, which means to subtract the powers. On your x's, you've got 5 on top and 4 on the bottom. So 5 minus 4 would give me x left on top, because that's where more of them were. For my y's, you've got 6 on top and 3 on the bottom. 6 minus 3 would leave me 3, and so that's still going to be up on top. And then for your z's, a z here and a z there crosses out, so I don't put any z's in there. So that would be my answer, x, y to the 3rd power. If I was doing this example, 2x to the 3rd, y to the 6th divided by 10x, y to the 4th. I'm going to divide my big numbers. Well, the bigger number's on the bottom, so I have to say 10 divided by 2 is 5, and that 5 is going to be left on the bottom. For my x's, I've got 3 of them, and remember there's 1 of them there. 3 minus 1 would leave me 2, and there were more of them on top, so that's where the x's are going to be left. For my y's, I've got 6 on top and 4 on bottom. When you subtract them away, that leaves you with 2 of them on top. So I have x squared, y squared over 5. If there are more of them on the bottom, or if the bigger number is on the bottom, that's where they have to be left, okay? So that's how you do divide. Either spread them and cross them out and tell me what you got left, or use the shortcut, okay? The second thing that's in the 7.5 is the idea of distribute, divide. Previously, we've only distributed by multiplying. Now we're going to distribute by dividing. And they'll look like this. There'll be 7x squared plus 14x to the fifth, and all of it is divided by 7x. Not just one of them, but both of these need to be divided by 7x. So the first thing that you ought to do is to split it up into the two divide problems. You've got 7x squared plus 14x5, and you're dividing each one of them by 7x. So you distribute the bottom as a divide part on each one of them. Now then, your second step is to simplify each part. If I have 7x squared over 7x, well, the 7's would cross out. And if you have 2 x's on top and only 1 x on the bottom, then that's going to leave you with x. Plus 14 divided by 7 is going to be 2. If you have 5 x's on top and 1 x on the bottom, that's going to leave you with 4 x's. So you have x to the 4th. If you need to spread them out and cross them out to help you do that, then do that. Okay? Here's a second example. 35y to the third minus 14y to the fifth plus 21y squared. And I'm dividing all of that by negative 7y squared. You know, if there's a negative here, you're going to have to be careful with your signs. So that's why I've given you this example. First thing I'm going to do is to split it up. So I'd have 35y to the third divided by negative 7y squared minus 14y to the fifth divided by 7y squared plus 21y squared divided by negative 7y squared. So split it up into your 3 divide problems so that you can do it. Either spread them out or use the trick that we just talked about. Here, if you have 35 and you're dividing it by a negative 7, that's going to leave you with negative 5. One negative sign is not going to cross out. It's going to stay. And then if you have 3 y's on top and 2 y's on the bottom, that would cross out and leave you with just 1 y. In the next one, you've got negative 14 and you're dividing by negative 7. Well, the 2 negatives would cancel because I'm dividing, and 14 divided by 7 would be 2. But I got to put a sign in the middle there so it doesn't look like a multiplication. The 2 negatives crossed out and made it a positive, so you have to put a sign there to keep your terms separated. And then if you had 5 y's on top and 2 y's on the bottom, that would leave you with 3 y's. So that's why you say it's y to the third. And then for the last piece, if you have a 21 and you're dividing by a negative 7, that would be a negative 3. Notice the sign goes in the middle to keep the parts separated. And then y squared divided by y squared, well, the y's are going to cross out, so I'm not going to put a y with my answer. And so this is your answer, okay? So I can't combine like terms because this is a y cubed, and this is a 3, so I have to leave it that way. Remember, you can't put them all together if the powers aren't the same. For our final example, if you have x to the 4th plus 2x squared minus x, and I'm dividing the whole thing by x, I'm going to split it up, x to the 4th over x plus 2x squared over x minus x over x. If you have x to the 4th and you're dividing by x, this would be 4 x's and 1 x that would cross out. That would leave you with x to the 3rd. Here, there's not anything to divide the 2 by. And then x squared on top and an x on the bottom. One of those x's are going to cross out and you'll just be left with x. And then here minus. Well, if you've got x over x, the x's are going to cross out. That doesn't mean there's nothing there. Remember, there's an understood 1 there. So this answer would be x to the 3rd plus 2x minus 1. So if you see it looking like this, this is the distribute divide. You have to split up into your divide problems and then do each one of them as if it was a simple problem. And then your answer cannot be simplified anymore because they're not like terms. So that's all of chapter 7.